We will card into the system by using *4#, and then once the monitors have turned on, you can double-click on the SmartSem icon on the desktop. This will allow you to log into the microscope software. Remember that your login ID for the microscope software will be the first part of your RPI email address, commonly referred to as your RCS ID. This should also be set as the password. Remember that you will be using the Exchange button in order to load your sample. The Exchange button does the following things. It sets signal A to TV. It moves the stage to a safe position. It turns off the high voltage, and then it lowers the sample to a safe position. Also, don't forget to begin your logbook entries, as this is an easy way for me to keep track of system conditions for each and every user. Once you're ready to begin moving your sample, bring it up in the Z-axis so that you can actually see it in the infrared camera, as typically when the stage is at its lowest position, you will not be able to see your sample in the chamber scope image. This will be using the Z-axis. Remember that if your samples are very tall, it is entirely possible to impact the final lens, which will be noted in the software, and I would also appreciate that if this should happen, you let me know so that I can check out the microscope to make sure that no serious damage has been done to it when something like this occurs. Remember that you're going to position your sample looking for a small amount of shadow, as well as your sample being in focus. You can turn on the EHT by selecting EHT from the data bar, and then it will go to whatever your presets are. Remember that you should anticipate what sort of beam conditions you might need in order to image your sample without causing any potential hazards or beam damage to your sample. If you don't know where to begin, of course, I am always happy to provide you that information, as I have been looking at samples for quite a long time. Once you have gotten the beam on, adjust your focus at a low magnification, increasing the magnification until the image is out of focus. Repeat this series of adjustments until you get the sharpest possible image that you can. Once that image has been obtained, you can adjust the aperture alignment, and that is done when you see the image shifting when you change focus. Remember that aperture alignment can cause astigmatism, but astigmatism does not cause aperture alignment issues. So typically it is better to adjust the aperture first and then adjust the stigmators. If you see that the image is shifting in the y-axis, it is typically the y-axis that should be adjusted. If you see it shifting in the x-axis when the focus wobble is turned on, this is an indication that you need to adjust the x-axis. The only time this may be confusing is if you have a large amount of scan rotation turned on. The system unfortunately does not properly compensate for scan rotation when doing aperture alignment. Remember to keep increasing your magnification as you do this in order to adjust your image more precisely. The higher the magnification, the more precise your adjustments will be. This is due to the fact that the Zeiss software has magnification compensation built into it. So as you increase your magnification, the adjustments become less coarse and more fine. And as you decrease your magnifications, the images become, or adjustments become more coarse than fine. There is also a coarse fine designator in the status bar, which is the little red dot with the word coarse next to it. If you see a small blue dot, that would indicate that you are in fine adjustment.
Hello, and welcome to part 3 of the Carl Zeiss SUPRA 55 FESEM user training. At this point, you've gone through the process of setting up your sample, focusing and stigmating on your sample, doing your aperture alignment, and getting yourself a really good image. So here we are. We'll just run through that really quickly. And once we've done that, we can grab a quick picture. There are a few things to remember when you're taking an image. First of all, make sure that you have good brightness and contrast. Make sure that the image has a really good grayscale. Not too much white, not too much black. It's also great to remember to use round numbers for magnification so that it's easy to replicate magnification series from sample to sample. We'll just check our aperture alignment here real quick. As you can see, the image is shifting just a touch. So we'll come in and adjust the aperture until we get it to shift in and out, or go in and out of focus evenly without too much translation. Use a little beam shift here. We're at about 160,000x for the display. Adjust our stigmators. You can slow down the scan speed to get a little bit of noise reduction in there so we can get a better, sharper image. Looks good. We'll turn off the reduce box, and then we'll get ready to take our picture. We'll come in, double click on magnification in the data bar, type in a round number for magnification. If you want, you could use a little bit of scan rotation to square up the boxes that we're looking at here. And there we go. We'll use a little bit of stage shift. Beam shift is also available, so if you wanted to roughly line things up. Check our focus again. Now there are a few things to keep in mind when you're taking an image. The first thing is our most basic type of noise reduction is called pixel averaging. That's found over here on the scanning tab of the SEM control panel. And when we click on the noise reduction tab, we have a choice here of continuous averaging, which we really won't discuss. It's basically a frame average without the flexibility of frame averaging. We have pixel averaging, which is in essence a slow scan. We have a line average, line integrate mode. The average mode basically is similar to the integrate mode. It's just when it reaches the last line of the image, it doesn't freeze the image. It goes back and starts the scan over again. So in this case here, if you pick line integrate, when you do the line integrate, it would come in and take the picture for you. So a line average, line integrate basically scans each line of the image at the scan speed that you select, and then you have an n value, and the n value is the number of averages. N equals 1 is no averaging. So the larger the scan speed number, the slower the scan speed. The slower the scan speed, the longer the beam dwells at each particular pixel in the image, and the longer it takes to take the picture. Cycle time is the overall time that it takes to acquire an image. So at a cycle time of, or at a scan speed of 3, your cycle time is 377 milliseconds with an n value equal to 1. If I were to come in and give it an n value of 10, it will take about 3.6 seconds. Okay? And then you can actually see the scan progressing on there. So if we were to do n equals 100, it would come in and it's doing 100 averages per line, and then it's stepping down to scan the next line. Typically, other than slow scanning, this is typically the best mode of operation to do, is do a line average or a line integrate. As you can see now, it's taking about 35 seconds to take this picture, as it scans each line 100 times, and then it's going to come down. And then, since I did a line average, you'll see the scan cycle back around to the top again, and then start over again. As you can see now, that's 100 averages. If we were to make it 50 averages, you can see that the noise isn't significantly worse at 50, and it's only taking 17 seconds. If we were to do 25, again, still not a significant increase in noise, and it's only taking just under 9 seconds to take the picture. So in reality, it may be okay to only do an n equals 25. We come up and press the number 1 button. That will set you back to pixel averaging and a scan speed of 1. Okay, and also unfreeze the image. We'll come in, we'll do our line integrate. Okay, it's scanning at a scan speed of 3, n equals 25, for a total cycle time of 8.9 seconds. You'll see a little dot pop up in the corner, which indicates that the image is frozen. We'll do a right click, send to TIFF file, and then we can save the image. Okay, so in this case, this is the calibration grid, so we'll call it grid, and then we'll come in and save the picture. Okay, come back, press the number 1 button, check your focus again. Okay, come in, do 100,000. If we were to do the other type of averaging called frame averaging, it's basically going to scan the image and frame integrating. It's going to scan the entire image, put it into memory, and then scan each additional image and time. Okay? So if we were at a scan speed of 2, our n is equal to 1, and we were to make it 10, it's going to take 2.2 seconds to acquire that image. Okay? Or do n equals 100, it's going to take 22 seconds. Okay? So here, again, the image quality at 10 really isn't all that bad, so we could just actually use that. If we were to do the integrate mode, it would do exactly the number of frames that we dial in, and then it would freeze the image. Okay? So here we'll do frame integrate. Scan speed of 2, n equals 10. You get a little progress bar across the bottom of the screen, and then the image freezes. Okay? To save the picture, we would do right-click, send to TIFF file, and then we would save the picture into that directory. Okay? And then we could just change our magnification. If we wanted to center an object, we could do Control-Tab. Click on an object. Let's pick somebody who's unique, that little black spot there. If we wanted to do what's called center feature, we could draw a box. We would center the box and then increase the magnification for that box to fill the screen. Okay. Again, we like to use round numbers for our magnifications, so we would come in to do 200,000, and then we could come in and take that picture. Keep the dust charging up. Okay. Another thing to make sure that you make note of, that freeze on should actually equal end frame, so that if you decide to freeze an image that's not in integrate mode, it would automatically freeze that. All right?
Once you've made all of these adjustments, it's time to go find your area of interest. Remember that it is a good idea not to do all of your adjustments on the area of interest that you wish to image. You should do it in an area that's adjacent to this area so that you don't cause any potential beam damage if your adjustments are not made correctly for EHT or aperture size. Remember that the aperture size is controlling the amount of current that you are putting down onto your sample. Once you have all of these adjustments dialed in, remember that you should use round numbers for magnification. This will make it easier for you to reproduce imaging conditions from area to area and sample to sample. We have multiple types of noise reduction that are available to us in order to capture our images. The most basic type of noise reduction is called a pixel average. Pixel averaging is simply a slow scan. The larger the number you select for your scan speed number, the longer the beam dwells at any particular point in the image. As you change that number, as you make it larger, this will increase your cycle time. Cycle time is the amount of time that it takes to scan from the top of the image to the bottom of the image and then return to the top of the picture. We also have several other noise reduction modes. Probably the best and most used one will be your line average or line integrate. In any of the imaging modes or image acquisition modes, if you see the word INT after the option, that will mean that it will do exactly the number of scans that you have requested at the scan speed that you have selected. The N value is the number of averages to do, either in the line mode or the frame mode. Line averaging mode or line integrating mode will scan each line of the image N times at the designated scan speed. In frame average frame integrate, it will scan each image N times. So it will scan the entire image from the first pixel to the last and then return to the top and repeat this process N times. As you will probably notice that if you select the same scan speed and the same number of averages, the N value, in either frame average frame integrate or line average line integrate, those numbers for cycle time are nearly identical. Cycle time is basically the exposure time that you are exposing your sample to the electron beam. I frequently like to consider it a dose. The real advantage to selecting the correct type of noise reduction is that it allows you to distribute the electrons over the sample in different ways in order to prevent potential imaging artifacts from developing from either the scan selection, scan speed selection, or noise reduction mode. Once the image is frozen, you'll see a small dot in the lower right-hand corner, and then you would go in to save the picture. To save the image, you will go in and do a right-click on the picture, and then you select Send to TIFF file. It is best to save the images as TIFF files, as these are not lossy compression. The bitmap option is also not lossy compression, but it does not write data into the TIFF header. JPEGs are lossy compression, which means that you may lose some image information or data as you store the picture to file. Remember that when saving the image, it would be a good plan in order to give yourself a very simple file name and then allow the system to automatically increment the last digits on the file name. This just makes it a little quicker for saving the files, and then you don't have to worry about potentially overwriting any image by not remembering to change the file name. It's also good practice to make sure that you have set up a directory for each day that you image on the microscope, and then within those you could either set up directories for specific samples or just lump all of those pictures into one directory. Once you have saved the picture, you can click on the number 1 button in the user toolbar. This will bring you back to the fastest possible scan speed. The most basic scan speed we have, again, is called pixel averaging, which is essentially a slow scan. Once you've completed the imaging process, you can go to the user hard panel on the desktop, press the exchange button, which will then run the system through the exchange procedure, which in essence turns off the high voltage, moves the stage to a safe location, sets signal A to TV, which turns on the infrared chamber scope, and then it will vent the system, closing the column isolation valve, as well as stopping the turbo pump and backing pump. It will then admit air into the chamber, and after 2 to 4 minutes, the system will be at atmosphere, and you can remove your sample. Please be sure that once you have finished your session and you've removed your sample from the chamber, that you do turn the pumps back on and not leave the system at air at the end of your session. You can then card out using *5#, and your session will be complete. If there is another user there, do take the time to ask them if they would like you to leave the system at air in order to save them a bit of time as they begin their next session. Thank you, and if you have any questions, please feel free to let me know. I am more than happy to lend any assistance that I can. If you feel that you need help acquiring high-quality images, I will be more than happy to lend you assistance, as I've been at this for quite a long time, and that is one of the services that we happily provide here in the Nano Bay at RPI.